Hi everyone, this is the last part of the advanced mathematical inductions we're going to do, and we're going to check, this is our statement. We have to prove that the given statement is true for all natural numbers, no matter what next term occurs. So the first thing we're going to do is check for condition 1, and if condition 1 works, we can proceed. So we're going to check for when n equals 1, and we're going to plug it in here, and that should equal 2. So basically, I'm going to plug in 1 everywhere there's an n. 1 plus 1 is 2. And then we have 4 minus 1 is 3. This gives you 1/3 of 6, which equals 2, which does equal our 1 times 2, because 1 times 2 is 2. So basically that checks. Now we're going to check if it works for some k. So we're going to copy this down with a k instead of an n. So I'm going to write 2k minus 1 times 2k. All right, equals 1/3 k times k plus 1 times 4k minus 1. And we're going to, if it works for some k, then it should work for the next term. So I'm going to copy this thing down again. We have 1 times 2 plus 3 times 4 plus 5 times 6 plus, I always forget my plus dot 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 plus 2k minus 1 times 2k. Now, the next term, what we're going to do is these are linear terms here. I'm going to add 2 to the negative 1. So my next term for that part would be 2k plus 1. And for this one, this is like 2, I'm going to write it here. This is like 2k plus 0. So that's your slope, and you're adding 2. So the next term here is going to be 2k plus 2. All right. Now, we have to do the other side. And the other side is very similar. You're going to have 1/3 times k plus 1 times k plus 2. And it's going to be 4k. And since the slope is 4, we're adding 4. So it's going to be 4k plus 3. I'm going to rewrite that really quick. So it equals 1/3 k plus 1, k plus 2, and 4k plus 3. So this is our goal right here. And so I'm going to take this side here, shorten it up by using substitution. This part here equals this. So I'm going to substitute and write that 1/3 k times k plus 1 times 4k minus 1. And then I'm going to add my next term, which is 2k plus 1 times 2k plus 2. And the goal is for this side to equal this right side. So do I have anything in common here? I don't. So what we're going to do is simplify here so we can do the highest common factor. And what I'm going to do is pull out a 2 here. So let me write it again. Okay, so there's that part, plus 2k plus 1. And I'm going to factor out this 2. And we get k plus 1. Now the reason I did that is so I can factor out a k plus 1. We have one right here. So I'm going to factor out the k plus 1. So you get the k plus 1. And this helps us out quite a bit. 1/3 k times 4k minus 1 plus 2k plus 1. And then we have this plus times 2. And what I'm going to do is going to move it in front. I just want to put it in front so it's plus 2. So basically we pulled these two out in front. All right, and I'm going to write it down on the next slide so we have more room. So let me write it again. You're going to have k plus 1 look where I'm at. 1/3 k plus 1 times 1/3 times k times 4k minus 1 plus 2 times 2k plus 1. All right. Now, what I'm going to do is go ahead and multiply through by 1/3. So if you do that, you're going to get k plus 1 times 4/3 k squared minus 1/3 k. So I just distributed here. And then I'm going to FOIL this part out, or distribute, and get 4k plus 2. And simplifying further, I can pull out a 1/3. So I'm going to pull out, if I pull out a 1/3 here, what I'll get is 1/3 k plus 1 times 4k squared minus k plus 12k plus 6. So basically I multiplied everything through by 3. Do you see what I did? If you multiply this whole thing by 3, then you can pull out the 1/3. And that's what I did. So I took that whole thing and multiplied by 3. Now, simplifying, get k plus 1 times 4k plus 11k plus 6. And then when you factor this, you get 1/3 k plus 1 times k plus 2 times 4k plus 3, which is what we wanted it to look like. So we have proven that which had to be proven, and condition 1 and condition 2 have been satisfied. Therefore, the statement is true for all natural numbers n. Okay, thank you and have a nice day. Bye-bye.